Hello and welcome to this week's Developer Skill Sprint. My name is Brian Alexakis. I'm a Product Marketing Manager here at Embarcadero Technologies. You can find all my releases on my Twitter account at IoT Brian. Today's topic is an overview of OAuth 2.0. If you take a look at the Skill Sprint schedule, this week was supposed to be a SharePoint.com RESTful API, OAuth 2.0, and multi-device form designer demo. However, we are still internally working on the SharePoint.com demo, and today's presentation is a primer for that demo as the OAuth 2.0 concepts apply. This week, we will be taking a look at Misfit Shine, which is a vendor for an IoT gadget. It's a health tracker. More on that later. And they have a web service which implements OAuth 2.0, and we will take a look at that as a basic example, which will lead up to our forthcoming SharePoint.com demo. We will be releasing this in the near future as a blog. The information in today's skill sprint applies to all platforms and operating systems. It is over HTTP. We're going to get into this more later, but the implementation of applications that deal with OAuth 2.0 can take the form of a desktop application, native smartphone or tablet application, or even a browser-based HTML5 web app. In fact, OAuth 2.0 does not have anything to say on the platform the application is running on. You are watching a skill sprint. Skill sprints are quick, to the point, and feature a working demo to illustrate concepts. There is a lot to cover today, so let's jump right in. Before we jump into what OAuth 2.0 is all about, let's first examine the shortcomings of traditional client-server authentication approach. In the traditional approach, the username and password of the end user is used directly by a server to authenticate a request for user data. This means the third-party app may store the username and password, lest the user have to enter it every time they run the application. Servers have to support password authentication, which inherently is a security weakness. Third-party apps then are then provided overly broad access to end-user data because the end user doesn't really have any mechanisms to restrict what kinds of data is exposed to the third-party app. It also limits how end users revoke access entirely. Credentials are universal in that the username and password is universal, and so different third-party apps end up having to use the same set of authentication credentials. So blocking access can really only be done by changing the password, which universally would affect all third-party apps using that set of credentials. And also, any compromise in a particular third-party app would expose the end user's username and password. The goal of OAuth 2.0 is to provide a secure way for applications to gain access to end-user data, and at the same time to separate the need for third-party apps to use the end user's credentials, that is to say their username and password. The OAuth 2.0 authorization framework was developed by the Internet Engineering Task Force, the IETF, and is defined by the RFC 6749 specification. For links to this specification and many other links that I will mention during today's presentation, please visit the blog post for this week's skill sprint at embt.co/blog-OAuth2. The link is at the bottom of the screen and will be shown throughout the presentation. The specification document defines the abstract of OAuth 2.0 as the following. The OAuth 2.0 authorization framework enables a third-party application to obtain limited access to an HTTP service either on behalf of a resource owner, by orchestrating an approval interaction between the resource owner and the HTTP service, or by allowing the third-party application to obtain access on its own behalf. This specification replaces and obsoletes the OAuth 1.0 protocol described in a separate RFC, RFC 5849. All transactions regarding OAuth 2.0 occur over HTTP, HTTPS. I want to take a quick second and talk about REST in general. The ultimate goal of OAuth 2.0, again, is to provide applications access to end-user data. That end-user data is provided by a web service, which implements and exposes what is known as a RESTful API. REST stands for Representational State Transfer. Unlike OAuth 2.0, which is a protocol, REST is considered an architectural style, and the implementation of REST on a web service is considered a RESTful API. Because it is an architectural style, the implementation of a given RESTful API can vary greatly from one vendor to the next. Data is exposed over HTTP and enables third-party applications to take CRUD actions, which CRUD stands for create, read, update, and delete end-user data. These REST APIs are exposed by creating URI strings, which are then sent off as an HTTP request. End-user data and other kinds of data are typically sent out from a web service in a JSON format. However, other data formats can be used, like XML or Atom, but JSON is typically used. Before I get into the specifics of the OAuth 2.0 flow, I just want to talk about a couple of things regarding the Internet of Things, gadgets and devices, and how different IoT vendors are exposing the data that gets collected by these gadgets and devices over a RESTful API. Vast amounts of data are being generated by IoT gadgets and devices. This creates opportunities for new kinds of meaningful analytics. IoT data analytics creates a new revenue stream for the vendor. And even though end-user data is open and available over a RESTful API, the access to that data can be limited. When it comes to consuming end-user data, not all vendors will expose that data in the same way. Some will have rate limits to the number of API calls, and others will restrict the date range, allowing queries to go back, for example, only 30 days in the past. And this can cause problems to client applications that need robust and unfettered access to end-user data. Limitations placed by vendors on their RESTful API implementations can completely break deep functionality desired by a client application. Any change in the RESTful API structure can end up essentially being feature breaking. And one solution that you can consider to overcome this limitation is to use a middleware solution, for example, like enterprise mobility services from Embarcadero Technologies, to aggregate data into your own repository, therefore lifting these kinds of restrictions or limitations that you might encounter from a given IoT vendor. We are going to create more information along this topic. I just wanted to bring it up right now as something to keep in mind. If you start reading the documentation for a given vendor's implementation of a RESTful API that uses OAuth 2.0, you will likely encounter some vocabulary terms that are specific to the OAuth 2.0 specification. A resource owner represents the end user. And in the context of an OAuth 2.0 protocol, the resource owner needs to be capable of granting access to protected resources. This is typically done through a web portal, and we're going to get into more of the detail on this a little bit later. A resource owner, a resource server rather, represents the web service itself, which is typically a cloud solution. And the resource server is capable of identifying and processing valid access tokens, which then are exchanged for the actual protected resource. What is a protected resource? Well, a protected resource is some quantity of data which is provided by the resource server on behalf of the resource owner. Client is the application itself that requests a protected resource, and it also will provide the authorization of the resource owner, which typically is done with an access token. Client can be the form of a native app, HTML5 web app, or pretty much any other kind of application. The authorization server is a server that issues access tokens to the client on behalf of the resource owner, and the authorization server will handle the resource owner authorization process. Ultimately, the access token is provided to the client on behalf of the resource owner. And the RFC 6749 standard specifies an access token as a string denoting a specific scope, lifetime, and other access attributes. Access tokens are issued to third-party clients by an authorization server with the approval of the resource owner. The client uses the access token to access the protected resources hosted by the resource server. So I know that's a lot of words there and not too much in the way of a visual cue, so I'm actually going to present next a step-by-step overview of the abstracted OAuth 2.0 flow. In order for a client to eventually obtain an access token, it first needs to send an authorization request to the resource owner. This authorization request, in actuality, in terms of implementation on many vendors, is actually handled indirectly by the authorization server. I'm going to demonstrate this concept later in the presentation in the demo itself. After the resource owner provides authorization, the client then receives what is known as an authorization grant. There are different kinds of authorization grants depending upon I guess you could say depending upon the environment that the OAuth 2.0 specification is being used within. And typically for web services, it's always going to be providing an authorization grant in the form of an authorization code. Later, I'm going to cover what the other three authorization grant types are, but the majority of OAuth 2.0 implementations out in the wild are going to be using the authorization code type of authorization grant. The authorization code will later be exchanged for the access token. So let's see what that looks like next. After the client receives the authorization grant, the client then just turns right around and sends the authorization grant with other supplemental information, which will be shown in the demo, back to the authorization server for validation. Once the authorization server validates that the authorization code is valid, the authorization server will then generate a access token, and that access token will have typically a rather long validity lifespan. In other words, you don't have to constantly get new access tokens. It will then send the access token back to the client again over an HTTP call. So your client, depending upon the implementation by the vendor, will have to be able to receive HTTP calls. Now that the client is in possession of the access token, the client can start requesting protected resources from the resource server. And in order to do that, it creates HTTP calls, and with that call, provides the access token. Once the resource server validates the access token, the protected resource is sent back to the client. And again, typically, these transactions will be packaged into a JSON blob. Now, steps 5 and 6 will, in application, sort of happen in a loop, in that once the access token is obtained, steps 5 and 6 are really all that's required to obtain a protected resource. If you maintain a cache within your application of the access token, steps 1 through 4 only have to occur once, or only have to occur if the cached access token is proven to be invalidated. We're going to go into this concept in the demo and show you how you can use an INI file to cache an access token. Before I get into the demo, I want to quickly recap what the 4 authorization grant types are. Again, an authorization code is what you will typically find, as it is the most secure and most widely adopted. Implicit authorization grants are used within the context of a browser HTML5 web application. In that case, the authorization code process is skipped and access tokens are granted directly to the client. It's more efficient but less secure. Resource owner password credentials are used typically in high trust environments where a resource owner credentials are directly exchanged for an access token. And lastly, client credentials are used when the client itself, as opposed to the end user, are actually controlling protected resources. So those are kind of edge cases, and typically you're going to encounter, again, the authorization code as the authorization grant type. We're running up against the clock here, so I'm going to jump right into this demo. Please note that the demo application is available for download from the blog notes. Here I've got app method with a demo that I built. It will consume the Misfit Shine REST API. We're not going to be covering that part. We're going to be actually just talking about the OAuth implementation, OAuth 2.0 that is. So we have a number of REST components here. 3 sets actually, one for dealing with pulling down activity information, one for pulling down profile information, and lastly one set of components for actually obtaining the token, the access token. If we jump into the code here, I'm going to try and walk through really quickly what's happening here. So if I can grab this and move it over. Okay, so when the application runs, the user panel is hidden, and we're going to expose a web browser. Then first thing that we do is check and see if there's a misfit INI present on the file system. If it is there, we're going to read the INI file and look for a key value pair under the misfit label for an access token and its corresponding value. If there is no value, then we're going to trace out that there's nothing found, and in that case there is no pre-existing INI file. And then the web browser will remain shown and user validation will then occur in the Misfit portal. And if I actually switch back to the design view and take a look at that web browser, you can see that the URL here is pointing to the Misfit API, and it is preloaded with the client ID. And the client ID, through a separate process, is given by Misfit in order to identify this application. You'll also notice there is a redirect URI, which is an HTTP endpoint. It's not actually used in this step, but it's still required by the Misfit API to match the registered application. I can actually show you really quick on the back end. If I go to My Apps, App Method Test, that here I've defined an application domain, and this is just one of the ways that Misfit is checking that this endpoint is matching when the user goes to input their credentials. So once the user has entered their credentials into the web browser and hit submit, then that calls in a function call here that looks for the web browser finished loading, and Misfit will package the code, which again is the authorization grant type, within the response after the Misfit web service has validated that the inputted user credentials are in fact correct, and that the user then puts allow access. After they push the allow access button, then the web browser gets redirected, and that URL that gets loaded contains this a URL code called code. And then we basically take this code and input it back into the REST request parameter, thereby setting that code to the provided code. And again, this is a very temporary code that is going to be exchanged for a permanent access token. So we take that code, put it into the parameter list, we execute the REST request, and then when it gets returned, again, it does it in a JSON blob. All right, we're going to check if that JSON blob contains an error. If there is an error, then we spit that out. If it was successful, though, then that JSON blob will contain an access token. And so we basically take that access token, write it into the INI, and then use that access token in a follow-up API call for getting user details. So that is a really quick and dirty example of closing the loop on OAuth 2.0. If you'd like to get more information on this demo, it is currently featured on the App Method blog, and I will provide links to it in the blog notes. Well, that brings us to the end of today's skill sprint. There is a lot more detail to explore in the Misfit demo. I hope it served to illustrate how OAuth 2 is actually used in the wild. The blog post that goes with that Misfit demo goes into a lot of detail, not only regarding OAuth 2.0, but also how to use the REST debugger to use REST API calls and get end user data. And also, I would like to remind everybody that the SharePoint.com demo is forthcoming, and that this skill sprint hopefully will get everybody up to speed on the major concepts behind OAuth 2.0. Again, if you want to follow my releases, I will post everything that I put onto Twitter at IoTBrian. And all of the notes can be found on the correlating blog for this skill sprint today at embt.co/blog-OAuth2. Thank you very much for attending today, and I will now turn it over to the question and answer.
Yeah, Willems.
Yeah, so he was referencing first of all, thank you for showing up. I'm glad you enjoyed the skill sprint. And on the REST Google Task demo, he was asking maybe if we could show a sample on sending a post, i.e. a new task does not automatically work with the REST authenticator. To get it to work, you need to do a bunch of code stuff, and this way the access token is part of the request URL and not part of the body. Right. So I think we could definitely take a look at that. And Antonio asks, is there also a Delphi example? Well, there isn't specifically for this Misfit Shine demo that I showed. But David, do you know of any Delphi OAuth2 examples that might be floating around out there?
In the fall of 2013, I think it was November, there was, let me look, in the RAD in Action, there was a RAD in Action all about REST and enterprise. Let me find the landing page for that one. And there, Daniel Wolf showed using OAuth2 with connecting into Facebook, and he used a Delphi example. Let's see. I have to find the right RAD action. Hold on. Goes back a little bit to the multi-divide. Embrace and extend.
Well, while he's looking for that, I'll just
go ahead.
mention
yeah,
that
I'm close.
I'll certainly post that link in the blog notes, which are now live.
And I'm putting the URL in Antonio's question as well. So there's the link to the RAD in Action. It's called Embrace and Extend. Connect Your Infrastructure to Mobile. And it was by Danny Olaf and Danny Megan, Daniel Wolf, and Olaf Moyman. And there's a white paper you can download that covers the information and how they use the REST components. It also, that page has the link to the source code for the projects that were in the white paper. So in there, you should find an OAuth2 Facebook source code example. And Daniel Wolf, they did the talk in different sections, and he look for the section on OAuth2 and Facebook. It was near the end, like if there were 7 chapters, it was like chapter 6, I think, something like that. So that page has the links that you can use. And Brian, I can work with you to do since I know a little C++ and a little bit of Delphi, I can work with you to take your example and make it make a Delphi version.
Yeah,
sometime this week.
Yeah, and also it's worth mentioning that even though it was built in AppMethod, really the technology that we're illustrating here is platform agnostic, of course. It all just uses the same REST components. Thanks for Craig says, thanks for the example of OAuth 2.0 client. Thank you. I'm glad you enjoyed it. What are the options for OAuth servers in RAD Studio? Any examples or planned blogs on OAuth server?
I don't know that we've built a sample of a REST server that uses OAuth 1 and OAuth 2, but that's a good suggestion.
I do think there might be something that we're working on internally that might get into that. I'm not 100% sure. But it has to do with the EMS server, right? So the EMS server exposes a REST API for you, and in that situation, I imagine that OAuth would definitely be part of that equation. We've got a question from Daniel. I'm using Abyss web server. Can I use OAuth there? I don't know. Are you familiar with the Abyss web server is? Yeah.
I'm not. We support the components we have in the REST client library support OAuth 1 and OAuth 2. So
right.
If it's if that server supports OAuth 1 or OAuth 2, then just use one or the other component.
Yeah, and I suppose too it also depends on whether you are talking about from the client side or server side.
Yeah, if you're building server side, the REST client library components we have are for the client side.
Right.
We don't have any components for server side other than writing your own code to respond to requests that come in.
Right.
On the web server side. You can use Web Broker and then dispatch based on the URI there to do whatever your server side wants to do. The REST client components and what the demo was showing was working with some external service.
Right.
And Brian has links on his blog post, and there's some other samples that we have. We had a webinar in November of 2013 that showed how to use OAuth2 client-side component to connect to Facebook, for example, and to do some things with Facebook friends and other objects that are in the Facebook world, photos, videos, whatever.
Well, I think at this time I will go ahead and end the webinar. I appreciate everybody coming out today, and I hope you found it informative. Until next time, have a great day, and we'll see you then.